About the extra test 2 practice. Let's go over it because I want y'all to do well on the test. All right, so for this first one, we're looking for the velocity and acceleration graphs for this displacement graph. Okay. So we got 3 segments. All right, first section, we're making our velocity graph. Sorry, this is number 1, not an A. 1. This is a velocity graph. Okay. So our velocity graph is looking at the slopes of this line. Okay, so at the beginning, our slope is starting off flat, which means that our velocity should be starting off at 0. Then our slope gets more and more and more and more steep in the positive direction, so our velocity should be getting more positive. All right, whenever we've got an acceleration in here, it's going to be a constant one. Okay, so if you're going to have anything other than a flat line for your velocity, it's going to be a slanted line with a constant slope. All right, then the second section, it's flat, which means that our velocity is 0 because we have no slope. Okay, this last section, our slope is negative and it is constant, which means we should have a constant negative velocity. Okay, so there's our velocity graph, always looking at the slopes of this line. Our acceleration graph, looking at the slope of this graph. We've got a positive slope at the beginning and it's constant the whole time. So positive constant slope. Here, our slope is 0. Because it's flat. So our acceleration graph will go to 0. Our slope is also flat here. So it will stay at 0 for the rest of the graph. Okay, so there's our acceleration graph. Number 2, find the resultant force, calculate its angle as well. Okay, so the resultant force is going to be the hypotenuse of the triangle formed between the two of these. All right, and the angle is going to be that one because it is adjacent to our smaller side. Okay, so looking for our resultant force, we've got 2 sides and we're looking for our hypotenuse. So that'd be 15 squared plus 7 squared equals C once we take the square root. Okay, so 15 squared plus 7 squared taken to square root, oh no, square root of my answer. There we go. Oh, the square root of 274 is the square root of 274. Give me something useful. There we go. So we got 16.6 newtons. Okay, so we've got the magnitude. Looking for our direction. We've got 2 sides here. Let's just use tangent of our angle is equal to opposite over adjacent. Okay, so looking for our angle, we're going to have to take the inverse tangent. Okay, plugging in our numbers. We've got an opposite side equal to our eastern component. We've got an adjacent side equal to our northern component. So arctan of 7 over 15. All right, and we end up with an angle of 25 degrees. Okay, the direction of that angle, starting from our cardinal direction that's adjacent, it's being pulled to the east of north. So 25 degrees east of north. And there we go. Okay, next one, number 3. Find the horizontal and vertical components of this force. So we've got an angle of 15 degrees. We've got a hypotenuse of 60 newtons. Okay, if we're looking for that adjacent side, okay, we've got to find adjacent, we've got our hypotenuse. That means we're looking at cosine of our angle equals adjacent over hypotenuse. Okay, so getting adjacent, we're going to multiply h over. Okay, so hypotenuse times the cosine of our angle will give us that adjacent side. Okay, so that'll be 60 times the cosine of 15. Okay, plugging in our numbers, 60 times cosine of 15. What a useless number. There we go. So that'll give us 58 newtons. This away. All right, our vertical component, let's use sine. So sine of our angle equals opposite over hypotenuse. Solving for opposite, we're going to multiply hypotenuse over and plugging in our numbers. So 60 cosine 15, okay, which is equal to, sorry, why did it just change to cosine? Sine. There we go. That'll give us 15.5 newtons. So 15.5 newtons going upward and 58 going to the side. All right, we got our two sides. Number 4, an object takes a force of 2 newtons to start moving and has a mass of 5 kilograms. We're looking for the static coefficient of friction. Okay, so the formula that has static coefficient, or a coefficient in general, is this friction formula. All right, it tells us that it takes a force of 2 newtons to start moving, so that means that our friction force is 2. All right, our normal force, because we're looking at just an object sitting on the ground, our normal force will be equal to the weight of the object, which is going to be mass times gravity. Okay, so mass is 5, gravity 9.8, so we end up with a normal force of 49. Okay, so now looking for mu, that's going to be 2 divided by 49. So mu, our coefficient of static friction, is 0.041. Okay, don't have to worry about units there, it doesn't have any. The floor has a kinetic coefficient of 0.02. Calculate the kinetic friction force, all right? So looking at the same formula, but solving for a different thing. All right, in this one, it's telling us our coefficient of friction. We've got 0.02. Notice that it's smaller than your static coefficient of friction. And we're going to be multiplying by our normal force of 49. Okay, so 49 times 0.02, and we end up with a friction force of 0.98 newtons. Cool, and we're done with that one. Number 5, a ball is thrown downward off a 30-meter high cliff with a vertical velocity of 2 meters per second and a horizontal velocity of 3 meters per second. How long does it take to hit the bottom? Okay, so we've got initial vertical velocity, we've got distance, we've got acceleration equal to 9.8, and we're looking for time. No one wants to do that because it's using formula B. So let's use formula C first to figure out what our final velocity is. Okay, so moving formula C around to solve for VF, we've got our initial velocity. Plugging that in, all right, it's being thrown downward, okay? So let's say that downward is positive. That'll make things easy for us because all of our directions on this are downward. It's falling downward, it's displacing downward, and it's accelerating downward. Okay, so our acceleration is 9.8 due to gravity, and our distance was the 30 meters that it was falling. Okay, so basically we got 4 plus 2 times 9.8 times 9.8 times 30. Taking the square root of our answer, and that leaves us with 24.3 meters per second. Okay, so now we're going to use that to figure out the time that it took. All right, we can use formula A, moving that around, which is VF minus VI over A. Plugging in our stuff, our final speed was 24.3 minus our initial speed of 2 divided by our acceleration of 9.8. So this minus 2 divided by 9.8. There we go. And we end up with a time of 2.23 seconds. Cool. Next bit, how far horizontally does it land? Well, that's horizontal stuff. We've got a horizontal speed of 3 meters per second. Okay. And we've got a time of 2.23 seconds. So we can just use formula 0, where Vx equals x over t. Looking for x, so we're going to multiply t over. Okay, Vx, our horizontal velocity, is 3. Our time is 2.23. So we're just going to multiply those two together. And we end up with a horizontal distance of 6.84 meters. Right on. And we are done with our second review. If you have questions about how I did those, either these or the ones on the last review, make sure that you send me those questions via Schoology before the test. Okay? Make sure you make a note card with any and all formulas that you feel you might need. So all your kinematics stuff, your F equals ma, your formula for weight, your formula for friction, and if you need to, your trig functions, SOHCAHTOA, those. All right? Ask me any questions you run into. See you guys later.